Hi, in today's video I would like to introduce you a very nice proof. It's called the Cauchy product of the power series. We are going to give the general proof and example, okay? So now let's get started. Let the sum A sub n and the sum B sub n as a convergent series. Denote the notation, the sum of C sub n is their Cauchy product. Replacing A sub n and B sub n by A sub n x sub n and B sub n and x sub n. So thus the power series A sub n x sub n and the power series B sub n x sub n are convergent series. If we have this as absolutely convergent, if you have this condition, x is strictly inferior than r, convergent series. Okay. We have the product of C sub n as n goes from 0 to plus infinity as a power series equal to the product of A sub n is multiplied by x sub n to the n as n goes from 0 to plus infinity is multiplied by the sum of B sub n is multiplied by x to the n as n goes from 0 to plus infinity. Okay, this product is given as the sum of as n goes from 0 to plus infinity is multiplied by another sum as k goes from 0 to n is multiplied by A sub k to the x to the k is multiplied by B sub n minus k is multiplied by x to the n minus k. Okay, I'm going to simplify this one more. So this product as n goes from 0 to plus infinity is multiplied by another sum A sub k. I'm going to put A sub k and B sub n minus k together. I will have is B sub n minus k as k goes from 0 to n is multiplied by x to the n minus k plus k. Okay, k will be cancelled out because we have k minus k. I will be left with this one. So the product of both power series equal to this one. So I'm going to prove this one. Now we are going to prove this one. We have the sum of A sub n is multiplied by x to the n as n goes from 0 to plus infinity equal to A sub 0 plus A sub 1 is multiplied by x plus A sub 2 is multiplied by x squared plus A sub 3 is multiplied by x cubed and so on and so forth until we get the last term, which is A sub n is multiplied by x to the n. Same thing with the B sub n, the power B sub n x to the n as n goes from 0 to plus infinity equal to B sub 0 plus B sub 1 is multiplied by x plus B sub 2 is multiplied by x squared plus B sub 3 is multiplied by x cubed and so on and so forth until you get the last term, B sub n x to the n. Now I'm going to do the product of this one. So the product of E sub n x to the n is multiplied by another power series B sub n is multiplied by x to the n as n goes from 0 to plus infinity. If you take a look, when you apply the product on first term, we have only one way to calculate the product of A sub 0 and B sub 0. Okay, so we'll have first term A sub 0 plus A sub 0 is multiplied by B sub 0 is multiplied by x to the 0. For the second term, we have two ways to calculate the power x. Okay, so the first one, I'm going to multiply e sub 0 by b sub 1 plus e sub 0 is multiplied by b sub 1 plus another way to calculate this one. So we have 2. So for this one, e sub 1 is multiplied by e sub 0. E sub 1 multiplied by b sub 0. These two terms are multiplied by x, okay? So there is no another possibility where you can get the x power. So we have these two. For the third term, for the third term, x squared. So how many times? So I'm going to calculate this coefficient. How many ways I can do that? So the first term, for the x squared, I can multiply a sub 2 multiplied by b sub 0. So we have a sub 2 is multiplied by b sub 0 plus for the second term, for the second coefficient, we will have a sub 1 is multiplied by b sub 1 plus e sub 1 is multiplied by b sub 1 plus another possibility. So this one, e sub 0 is multiplied by e sub 0 is multiplied by b sub 2. E sub 0 is multiplied by b sub 2. The whole thing is multiplied by x squared. For the third term, so I'm going to calculate for the x cubed. X cubed, I'm going to multiply this one by this one. So we'll have e sub 3 is multiplied by b sub 0. For the second term, I will have e sub 2 is multiplied by b sub 1. For the third term, is multiplied by b sub 1 plus e sub 1. E sub 1 is multiplied by b sub 2. For the last term, I get e sub 0 is multiplied by b sub 3. The whole thing is multiplied by x cubed. Okay, if you take a look at here, so generally as you go more up in the x power and you find more coefficient, and it will be more complicated to determine all the coefficient, because it will be hard and hard to get them. However, if you take a look at each term, you will find kind of patterns between terms. Okay, so e sub 0, b sub 0. The second term, e sub 0 multiplied b sub 1 plus e sub 1 b sub 0, and so on and so forth. There is very strong relationship between these coefficients. I can do something with this coefficient now. So we'll have the double sum as n goes from 0 to plus infinity. The second sum, I will have k goes from 0 to n. Since I found the kind of patterns between coefficients and terms, since I found the kind of patterns between this coefficient and the power x, so I will write e sub k is multiplied by b sub n minus k is multiplied by x to the k is multiplied by x to the n minus k, because there is straight relationship between coefficient and power x. That's why I put x to the k, because let's take the first term as an example. For the e sub 0, b sub 0, if you take a look, if you take k equal to 0, replacing k with 0, we will find k e sub 0, bn minus k. N is you have the 0 power, so that means 0 minus 0, which is 0. For the x, you have 0 power, x to the 0, and n you have 0. The maximum terms, we have 0 minus 0, which is 1. So exactly what I have written here was true. So in the same time, this one, I can simplify this one. So we'll get n equal to 0, as n goes from 0 to plus infinity. Double sum, second sum, as k goes from 0 to n. A sub k is multiplied by b sub n minus k is multiplied by x to the n, because x is given as x, n minus k plus k will be cancelled out. I will be left with this one. Okay, now this is our proof. Now let's move on to an example. We have 1 over 1 plus x as a geometry series. Now I'm going to calculate the product of this one. That's mean 1 over 1 plus x quinary square. So I will calculate 1 over 1 plus x quinary square by applying the Cauchy product of power series. So I will get minus 1 to the n, as n goes from 0 to plus infinity, is multiplied by x to the n. The whole thing is multiplied by another product, which is the same product itself, because we have quinary square, as n goes from 0 to plus infinity. Now, by applying the Cauchy product of this power series, so 1 over 1 plus x quinary square is giving us the sum of n as n goes from 0 to plus infinity, is multiplied by another sum. So the first term I will have minus 1 to the k, as k goes from 0 to n, is multiplied by x to the k, is multiplied by minus 1 to the n minus k, is multiplied by x to the n. Okay? Now I'm going to simplify this one. This one is giving us, as n goes from 0 to plus infinity, is multiplied by this sum, as k goes from 0 to n, the sum of minus 1 to the k. So I'm going to put these terms together. I will have minus 1 k is multiplied by minus 1 to the n minus k, and this is multiplied by x to the k, multiplied by x to the n minus k. Okay, so this one, so these two terms, I put them together, I will get minus 1 to the n, because k will be cancelled out, because we have k minus k. If I put them together, this one, the same thing here, I will get k plus n minus k, which is x to the n. So this one is giving us the sum, the first sum as n goes from 0 to plus infinity, is multiplied by another sum, which is minus 1 to the n minus k plus k. The second one, I will have x to the k minus k plus n, as n goes as k goes from 0 to n. Okay, so consequently 1 over 1 plus x quinary square is giving us the big sum, as n goes from 0 to plus infinity, is multiplied by, if you take a look again at this sum which is inside is written in term of n, but this one is considered as a constant. I can take this one outside because it's not related to the k. Okay, so I put this one outside, calculate how many terms that I have here. So we have n plus 1 term. So this big sum, as n goes from 0 to plus infinity, is multiplied by minus 1 to the n, is multiplied by x to the n, is multiplied by n plus 1 term, because this one I have n plus 1 term. So I can rewrite it in the nice way. So 1 over 1 plus x quinary square equal to this sum, as n goes from 0 to plus infinity, minus 1 to the n, is multiplied by n plus 1, is multiplied by x to the n. Okay, now I have evaluated this product. I have done with this problem. Just consider to subscribe. Thank you for watching. I will see you in next video. Bye.